more difference of squares. So let me just put it up there. Oops. More difference of squares examples, right? And in the next few examples, what I'm going to do is I'm going to only look at using the shortcut. I'm not going to do things the long way, using the full FOIL method or multiplying the binomial by the full binomial. We want to observe this and we want to see what type of product it would result in. So I'm going to give you a plus 3b, and if this is a difference of squares, then I have to multiply by a minus 3b. Now remember, there is a long way to do this, where I multiply that by that by that, this by this, and then I look for the like terms, and the middle two terms always cancel out. That's just how it works. So to convince yourself that this is true, I recommend that you also do it the long way. But the short way when we have two brackets or two factors, where the one is just a sum of two terms and the other one is the difference, in other words a minus 3b of two terms, then all I need to do is multiply the first term, a with the a, do you see that? And I need to multiply the second term, like that, right? And then we get the following, and we say, well, a times a is just a squared, a positive times a negative is a negative, 3 times 3 is 9, and b times b is b squared. It's as simple as saying the definition of a difference of squares is if I have a plus b and I multiply that by a minus b, I must get the equivalent of first times the first, which is a squared, minus, that gives us the difference, b squared. And this is the reason that it's called the difference of squares, because this is a perfect square and this is a perfect square, right? It doesn't have to be a perfect square, it just needs to be a square, which is something we'll talk about a little bit later. Okay, remember you can do this the long way, and I'm going to put it out there. Try the long method, sometimes known as FOIL, right? Okay, let's try another one. What about k plus 3? Well, for this thing to be a valid difference of squares, the other factor must be k minus 3. And this is very, very simple once again. That is k squared, and that over there is 9, and then I must minus. Now remember, this over here is just really the same as k times k, in other words k squared minus, and this over here is just 3 squared. And that's what simplifies into k squared minus 9. Okay, let's try another example. And remember, you must also try it the long way. Now this is clearly a difference of squares because I've got one factor with two terms. I've got another factor with identical terms. The only key difference is that these factors are separated by a minus sign and these factors are separated by a plus sign. So what I'm going to get is I'm going to get the following. I'm going to say, well, okay, it's just the first, then I have to put the minus down, and then I just have to multiply the last. So very, very easy over there, right? So that is equal to 2x times 2x, and you can work it out. 2x multiplied by 2x is 2 times 2, which is 4, and x times x is x squared. So this is going to be 4x squared, right? A negative times a positive is a negative, and 6y times 6y is 36y squared. Okay, so those are key difference of squares. Let me give you another one. Let me give you something with numbers. Root 2 minus 3 multiplied by root 2 plus 3. Is this a difference of squares? Take a moment. Well, if you said no, give me some reasons as to why you don't think it's a difference of squares. Or rather, that it would result in a product that gives you a difference of squares. And if you said yes, what's your reason? Well, it's quite simple. The reality is I've got one factor consisting of two terms separated by a minus sign. Then I have another factor consisting of two terms separated by a plus sign. And those are essentially the conditions for having something that will result in a difference of squares in its product. So let's work this out. It's going to be root 2 multiplied by root 2, and you can try that on the calculator as well. Root 2 times root 2 is just root 4, which is equal to 2 because the roots itself cancel out. That negative times that positive, that's going to give me the negative. And 3 multiplied by 3 is 9. And so this here is really the square of root 2. And this over here is really the square of 3. And so there you have a few key examples of difference of squares. I urge you to work through them. If you did not write this down, I suggest that you replay the video and write it down as we go through the examples. Because a good strategy that many of my past students have always used is to first watch the videos and then make notes during their second round of watching the videos. The good students, they pause during the video if they understand the work and they write that part down. So they engrave a neural pattern as they go along rather than wanting to see the full picture and the full answers. Okay.